Tutorial sheet 1, question 12. We're given a situation as here where we have an input signal x of t, which is a u of t, which is a unit step function, which is going through two systems, system 1 and system 2, and each of those systems has an impulse response which is exactly the same, which is h1 of t is equal to e to the minus t u of t. This is the same for system 2, and we're asked to work out an equation for what is the output function y of t. Well, rather than trying to calculate this all in one step, what I'm going to do is split it up into two steps. So I'm going to have the input function u of t and calculate z of t. First of all, with the first impulse response, h1 of t. So if I write down the equation that we need, z of t, well, the manipulation of the convolution is actually easier if we flip the input signal rather than the impulse response. So I'm going to do the convolution of h1 of t with x of t. If we write that out, we have the integral of minus infinity to t of h1 of tau u of t minus tau d tau, which is equal to integral of minus infinity to t of e to the minus tau u of tau, which is the impulse response, just replacing t with tau, multiplied by u of t minus tau d tau. Well, how do we cope with this? Well, we know that this response, which is just a product of two unit step functions, but this only exists between 0 and t. So, and because this is a flipped version of u of t, so what we can do is we can change the integral from 0 to t, because this product only exists between 0 and t. And there we're just carrying out the integral of minus e to the minus tau d tau. And that's a relatively simple integration to carry out, which gives you 1 minus e to the minus tau multiplied by u of t, u of t. You have to remember, even though you've taken it out here, you got rid of these step functions to change the integral, you must remember to put it back again so that it does define that this function doesn't exist before t is equal to 0. So that is the value of z of t, so that's the equation we have for z of t, and now we're going to put z of t into system 2, which has the same impulse response as system 1, which is going to give us y of t is equal to h2 of t convolved with z of t. We don't really have any choice here. We've got exponentials in both formulas, so we're going to have to flip one of these. So that is the integral from minus infinity to t of h2 of tau z of t minus tau d tau, which is equal to the integral from minus infinity to t of e to the minus tau u of tau, which is h2 of t, multiplied by 1 minus e to the minus, now we're replacing t with t minus tau, and u of t minus tau d tau. So we've set up our equation that we need to calculate, and again these step functions allow us to just change the limits of this integration. So if we write that out again, the integration limits are now 0 to t, because this product of these two step functions only exists between these two limits, and that product is 1. So we've got the integral from 0 to t of e to the minus tau into 1 minus e to the minus t minus tau d-tau. If we multiply this out, the integral from 0 to t, and so we have e to the minus tau into 1. So first of all I'm just going to expand this bit out, so we've got 1 minus e to the minus t from this, and then multiplied by e to the tau d-tau. Again, we can multiply this out a little bit further, so we've got the integral from 0 to t, where we have e to the minus tau multiplied by 1, and then we've got e to the minus tau multiplied by e to the minus t e to the tau. So when we multiply e to the minus tau by e to the tau, those just cancel out, and so we're just left with e to the minus t. So this is the final integration that we need to do. And note that the integration variable is tau, which only exists in here. So we have to remember we're not integrating this e to the minus t, because t is a constant in this equation. So if we do that integral, and we can split the two integrals up, so we can integrate this function and integrate this function separately. If we integrate that first function, we get minus e to the minus tau between the limits of 0 and t, and minus tau e to the minus t between the limits of 0 and t. So we have to do this integration by putting the limits of t and 0, and if we work that out, we get 1 minus e to the minus t, which is this element, minus t e to the minus t. And we've got a couple of common parts in this equation, e to the minus t, so we can simplify that to 1 minus e to the minus t, all multiplied by 1 plus t. Relatively complicated, but my tip is to make sure that you take it in nice easy steps, make sure that you don't make any silly mistakes as you're going along, and take care with your integral limits, and you must have to practice your integration and keep practicing to get these right.